Hello everyone, this is the pre-launch news conference for the Orbiting Carbon Observatory-2 to be launched for NASA by United Launch Alliance aboard a Delta II rocket on Tuesday morning. We'll begin with our opening remarks from Betsy Edwards, the OCO2 Program Executive from NASA headquarters. Next, we'll hear from Tim Dunn, who's the NASA launch manager during the countdown from the Kennedy Space Center and the Launch Services Program. Vernonthorpe, the program manager for NASA missions from United Launch Alliance. Ralph Basilio, the OCO2 project manager from the Jet Propulsion Laboratory. And Lieutenant Joseph Round, the launch weather officer from the 30th Operations Support Squadron at Vandenberg Air Force Base. And we'll begin first with Betsy Edwards, our OCO2 program executive from NASA headquarters. Betsy?
Thank you, George. Good afternoon. The Orbiting Carbon Observatory-2, or OCO2 as we call it, will launch from the Vandenberg Air Force Base very early Tuesday morning, joining many other 17 specifically other Earth science missions in watching the Earth as a system. As we can see in our first picture, there are currently 17 spacecraft studying various elements about the Earth as a system. And OCO2 will join these in measuring the global carbon dioxide concentrations, carbon dioxide being the greenhouse gas that drives climate change. This is an auspicious year for Earth science, as it will see 5 mission launches that, together with our existing operational missions, will look at some of the most pressing issues facing our planet today. Issues like sea level rise, extreme weather events, freshwater resources, and of course, climate change. Because climate change is the challenge facing our generation. And NASA is uniquely positioned to take on the challenge of documenting and understanding climate change, predicting its impacts, and sharing the information about climate change for the benefit of all of society. And with the launch of OCO2, if we could see our next video, with the launch of this spacecraft, decision makers and scientists will get a much better idea of the role of carbon dioxide in climate change, as OCO2 measures this greenhouse gas globally and provides incredibly new insights into where and how carbon dioxide is moving into and then out of the atmosphere. Now, the OCO2 spacecraft consists of a single instrument, but with that one instrument, OCO2 will collect hundreds of thousands of measurements each day. And these measurements will provide us with a global description of carbon dioxide levels with an unprecedented coverage and resolution that we've never had before, because this is our first mission dedicated to studying carbon dioxide in the Earth's atmosphere. In our next video, we can see how OCO2 is in a polar orbit, and with this orbit, it will see locations on the Earth at the same time of day, approximately every 16 days and across all the seasons, providing us more insight into the changes in carbon dioxide levels over time. And ultimately, scientists predict that looking at these changes over time will give us patterns that are weeks or months or years long that will help them to unravel the mysteries of the carbon cycle. Now, the OCO2 mission came into being because of the 2009 launch vehicle failure that was carrying the original OCO spacecraft. But because of the importance of this measurement, NASA was given permission to rebuild the spacecraft and launch. Now, right after the launch failure, the Japanese science team for their greenhouse gases observing mission, the GOSAT satellite, the science team reached out to NASA and invited the OCO science team to participate with them in analyzing the GOSAT data. And by doing this, We are sharing our information, we're sharing processes. The OCO science team has really refined their data processing algorithms because they've had a chance to work with some real data. And of course, this collaboration is only going to be strengthened when we offer them the OCO2 science data at the end of the year. And the scientists are eagerly anticipating the opportunity to merge the OCO2 science data with the GOSAT science data and help to understand, improve their knowledge of the global carbon cycle. The OCO2 mission will join NASA's very robust Earth science program consisting of both space-based and airborne observations, ground-based measurements, and of course our data analysis capabilities, in yielding unprecedented, unparalleled new knowledge about the Earth as a system. We're all anxiously awaiting the launch of OCO2 Tuesday morning as we all wait to see the Earth breathe. Back to you, George.
Thank you, Betsy. And now to Tim Dunn from the Kennedy Space Center, who is the NASA launch manager during the countdown. Tim?
Thank you, George. I'm proud to be here today representing the men and women of NASA's Launch Services Program. I'm the NASA launch manager for the OCO2 mission, and I'm thrilled to serve as launch director for a Delta II launched spacecraft that will be NASA's first Earth remote sensing satellite to study carbon dioxide in our atmosphere. My high school chemistry teacher, Mrs. Ballou, would have loved this mission. After almost 3 years since the last Delta II launch, I'm here today to tell you that the Delta II launch team is back. OCO2 will launch on a Delta II 7320 vehicle from Space Launch Complex 2, affectionately known as SLC-2. The OCO2 mission will be the 367th Delta rocket to launch since May of 1960, and SLC-2 is proud to have hosted 81 of those Delta launches. Over the past week, the Delta II team has been busy with many launch preparations. Last Tuesday, the combined NASA and United Launch Alliance launch team held the flight readiness review. We assessed the preparations of the Delta II launch vehicle, range and facility assets, and the readiness of the OCO2 spacecraft. A day later, last Wednesday, we performed a successful mission dress rehearsal of the entire team. That same day, the ULA crew loaded the hypergolic propellant of nitrogen tetroxide on the second stage, followed a day later by the Aerozine 50, which is the fuel for the second stage. Now I'd like to show a video of the ULA crew building up the Delta II launch vehicle that will launch our spacecraft from SLC-2. Please roll the tape. Here we have a view of the first stage for OCO2 being transported up to SLC-2 and put in the horizontal processing facility. This is a nice view of the payload fairing that will encapsulate the spacecraft at the top of the Delta II. ATK in Iuka, Mississippi makes our payload fairing. It's a 10-foot diameter composite payload fairing. This occurred toward the end of March. This is a nice view of the first stage after it had received horizontal processing at Vandenberg, being erected onto the launch mount at SLC-2. You'll see it's being raised up by the crane on the mobile service tower, and then it'll be translated over onto the launch mount and mated. That's a nice view of the Aerojet Rocketdyne RS-27A engine, 237,000 pounds of thrust coming off the launch pad. Next, we move into the solid rocket motor erection sequence. OCO2 will have 3 SRMs attached to the first stage. ATK makes these GEM 40-inch diameter SRM motors. Each of them have a thrust of 111,000 pounds. Again, we use the MST crane to mate them to the first stage. This is a view in the middle of April of moving the second stage out to SLC-2. That occurred on the 15th of April. Aerojet Rocketdyne makes the power plant for the second stage. That's the AJ-10 motor, thrust of 9,300 pounds. And then about just a few weeks ago, the middle of June, we erected and mated the OCO2 spacecraft. You see it here in its transportation can, moving out to SLC-2, being erected and then it'll be gently set down and mated to the top of the second stage. You see the ULA team working there very carefully. It's a very delicate operation, and that's a beautiful shot revealing the OCO-2 spacecraft. An even better shot there during payload fairing mate. The spacecraft was unbagged. You see one half of the composite payload fairing around the vehicle, and here you see the second half being positioned into place. This activity occurred on the 21st of June, and then you'll see the launch crew doing final inspections of the separation seam. And that's just a nice view inside the clean room at Slick 2 of the fully mated payload fairing around the OCO-2 spacecraft. This afternoon, we held a successful launch readiness review where we received approval from senior NASA and ULA management, as well as spacecraft and range agencies, to proceed into launch countdown tomorrow night. At Slick 2 today on the rocket, we performed the range safety and beacon checks, along with the first and second stage engine slewing checkout and the final azimuth alignment update for the flight computer. Tomorrow afternoon, we will begin final launch pad preparations at approximately 3 p.m. Pacific time, when we load refined kerosene or RP1 fuel onto the first stage, and then we'll move the mobile service tower away from the rocket to the launch position. The launch team will arrive on console just after 10 p.m. Pacific time Monday night, and we will perform final preparations of flight computer power on and pressurization about midnight, followed by first stage liquid oxygen loading at 1 a.m. Tuesday morning. Final engine slews will be performed at 2 a.m., and then we'll be ready for launch at a T0 of 2:56 and 44 seconds a.m. Pacific time with a 30-second launch window. In summary, the rocket is ready and the launch team is prepared and excited to be back in business with Delta II and poised to launch this important spacecraft for our nation. Back to you, George.
Thank you, Tim. And now to Vernonthorpe, the Program Manager for NASA Missions from United Launch Alliance, to discuss the Delta II's flight events. Vern?
Okay, thank you, George. United Launch Alliance, our entire team is honored once again to be here at Vandenberg 2 days before the launch of the OCO-2 satellite. ULA started working with NASA to integrate the OCO-2 spacecraft onto Delta II about 2 years ago in the summer of 2012. We also began building the vehicle for this mission in Decatur, Alabama at about that same time. As always, our ULA team has worked very closely with NASA, the spacecraft team, and our other mission partners to get us to this day, and it's been a tremendously successful team effort. We look forward to a great launch on Tuesday morning. OCO-2 will be ULA's 7th launch of the year. In addition to being NASA's 51st Delta II mission, it will also be ULA's 84th mission over the last 7.5 years. We currently have a very busy manifest with 15 missions scheduled in 2014. I mentioned that this will be our 7th of those 15. Those 15 include 5 launches from Vandenberg Air Force Base, and I'd like to note that we actually have 4 vehicles on 4 different launch pads right now, and we're prepping all those vehicles for launch in about a 6-week period coming up, beginning with OCO-2. Our 15 missions this year include 3 launches for NASA. OCO-2 is the second of those 3, and we've actually got a 4th launch for NASA planned later this year. We're going to be launching a Delta IV Heavy out of Cape Canaveral in support of NASA's exploration program. The OCO-2 mission marks Delta's 2 return to flight after a 3-year hiatus. It's the first of 2 planned Delta II missions scheduled to fly this year for NASA. The Soil Moisture Active Passive, or SMAP mission, will also be launching on Delta II this fall. NASA also selected Delta II at about the same time to launch the Joint Polar Satellite System satellite and also the Ice Cloud and Land Elevation satellite. Those missions will be in 2016. The specific Delta II we're using for OCO-2 is a 7320 configuration that features the first stage booster powered by an Aerojet Rocketdyne RS-27A engine, 3 Alliant Tech Systems strap-on solid rocket motors, and an Aerojet Rocketdyne AJ-10 engine will power the second stage. The payload is protected by the 10-foot diameter composite payload fairing, as you heard Tim mention. Now I'd like to show a video of the launch sequence for this mission, and that'll give you a preview of what you can expect to see during or just after the countdown. So here's the Delta II on the pad, same configuration that we'll be using for OCO2. And there you see liftoff. The next major event that you'll see on July 1st will come just after a minute into flight. Will burn out, or the solid rocket motors will burn out, and at 99 seconds into flight, you'll see those jettison. We'll jettison all three of those at once. And after we jettison those three motors, which you'll see here in just a second, that core stage will continue to burn until we've used up all the propellants. We hang on to the solid rocket motors for about 30 seconds after they burn out for range safety reasons, so they splash down in a safe spot in the ocean. So there you see the core continuing to burn. That'll burn for a little over 4 minutes from liftoff. At that point, we'll shut down the engine. About 8 seconds later, the second stage will separate, and we'll begin the first of 2 engine burns required to place the satellite into its required orbit. About 23 seconds into that first burn, we'll jettison the payload fairing, as you just saw. And that first burn will last about 5 minutes and 42 seconds. We go into a 40-minute parking orbit then. That puts us into the proper position for the second of the 2 burns required. That's a short 12-second burn, and 5 minutes later we separate the spacecraft, as you saw there. Now, once we're done with the primary mission, and that takes about an hour, it's about 56 minutes and 15 seconds after liftoff is when we plan to separate the satellite. The Delta II upper stage will actually continue on. We've got 2 more burns planned after separation. Those will occur over the following hour, and that will put the second stage into a safe storage orbit where it won't pose a danger to any other satellites. So ULA is proud to serve a critical role in delivering payloads to orbit for all of our government and commercial customers. And we're focused on perfect product delivery for this and every mission we launch, and we do that 1 launch at a time. ULA maintains a relentless focus on successfully delivering critical capabilities to orbit, and mission success for our customers is what drives us. It's always an honor, and it's always exciting to be part of these unique NASA missions. So I'd like to just say thank you once again to all of our mission partners. The entire ULA team looks forward to a great launch starting with the countdown tomorrow night. And with that, I'll turn it back over to you, George.
All right, thank you, Vern. Now to Ralph Basilio, the OCO2 project manager from the Jet Propulsion Laboratory. Ralph?
Thank you, George. It's indeed an honor and pleasure to be here this afternoon or early evening. NASA's Jet Propulsion Laboratory and Orbital Sciences Corporation have been working very hard since March of 2010 for the OCO2 mission. We want to be able to deliver on the promises that were made on the original OCO mission, basically to obtain carbon dioxide measurements from space with the precision, resolution, and coverage needed to improve our understanding of the carbon cycle and the global climate change processes. Now, the OCO2 observatory is not an identical twin of the original observatory, but sometimes it's referred to as a carbon copy. Now, we took full advantage of all of the existing designs and the documentation from the original OCO mission to mitigate risk with this implementation. I am proud to say that we fully expect to meet our technical, our schedule, and cost commitments that we made to our NASA sponsors. Now let's roll the first video, please. So the observatory itself is made up of a standard spacecraft bus that was adapted for use on the OCO2 mission. And we have a single instrument. It's a 3-channel grating spectrometer. And we subjected the observatory to a comprehensive series of ground tests, a successful set of tests. And these tests included subjecting the observatory to the simulated environments of space. So the cold and hot temperatures extremes, as well as the vacuum of space. We also simulated the environments that the observatory would expect during launch operations. Now, after we completed all of our observatory testing at the orbital facility, we shipped here to Vandenberg Air Force Base, and you can see footage here of the shipping container lid being moved away from the observatory and the unbagging process. The bag is there basically to protect the observatory from any contaminants, as well as to provide some humidity and temperature control. Now, the technicians here are now preparing the observatory for what we call mating operations with the payload stack. And the mating operations was completed after we fueled the observatory. And this is a nice image of the observatory being lowered. And you can see the compression springs that will actually push the observatory off of the launch vehicle at the designated time. And the payload stack includes what we call a soft ride vibration isolation system. Due to the relatively low mass of the observatory, we basically need a shock absorber, if you will, to make sure that the loads are at the required states. And you can see here the technicians are now preparing what we call the container or the can. The can is used to protect the observatory from the outside environment, so temperature, humidity, contaminants. You can see here that the completed can is now being hoisted above the observatory and being moved over to the proper location and then gently lowered. And that process took a little bit more than about half a day to complete, and you can see the can itself now being lowered into place and bolted into position. And after the can was fully assembled, the technicians in the clean room moved the completed observatory located inside the can over to the transportation cart. And the payload processing facility is located only about 2 miles from what we call SLIC 2 or Space Launch Complex 2. And the transportation took place in the early morning hours. With the low wind conditions, we wanted to make sure we didn't have any kind of situation to contend with. And it was actually a perfect transportation with no issues. You can see here the observatory now mated with the rest of the launch vehicle. This is the clean room inside of the mobile service tower. Now I'd like to go ahead and speak to you a little bit about what to expect after the 2:56 a.m. launch on Tuesday, the 1st of July. So let's go ahead and roll the next video clip. It's actually an animation, and I want to direct your attention here. So about 5 minutes after the launch itself, the payload fairing, which protects the observatory, will separate and be jettisoned away, exposing the observatory to the cold vacuum of space. Now, after a relatively long unpowered flight, the observatory will separate from the launch vehicle's second stage, and we hope to be able to capture this separation event with a forward-facing camera that's mounted on the launch vehicle's second stage. So about 3 minutes after the separation event, the observatory will begin a series of what we call autonomous commands or pre-programmed commands. And one of the most important commands is to begin the solar ray deployment sequence. So again, about 3 minutes after a separation, this 10-minute solar ray deployment sequence will begin. That will begin to provide the solar power that's needed to operate all of the spacecraft components that are on at that time. And we'll be making our first health status check about 2.5 hours after launch, so about 5:30 a.m. Pacific Daylight Time. So after we complete the health checkout, we will begin to go ahead and configure the spacecraft bus for in-flight operations. Now that's going to take on the order of about 1 to 2 weeks. We want to be diligent. We want to make sure that everything is good. And let's bring up the still. And this is a artist rendition of what we call the A-Train or afternoon constellation. It's a series of Earth-observing satellites that are actually flying in loose formation above the Earth. Now, after the spacecraft checkout, that'll take on the order of about 1 to 2 weeks, we will begin a series of propulsive maneuvers to raise the altitude of the observatory to the requisite 705 kilometers. And that's where the OCO2 observatory will take its rightful place as the lead satellite in this A-Train constellation. So this constellation is actually there because it provides a very useful virtual platform in space. There are a number of different science instruments on each of those satellites, and collectively they're going to create a superset of information. We will have basically a set of scientific information that complement one another by allowing the OCO2 observatory to be operating as part of the A-Train constellation. So once we're in the right orbit and flying in formation, we will take on the order about another week or two to fully check out the instrument. We're going to take a very slow, systematic, methodical approach to make sure that the instrument behaves in space as it did on the ground with our comprehensive ground validation test program, as well as the calibration activities that we completed here on Earth. And as far as nominal operations go, every 16 days, the observatory is going to transition from what we call nadir mode operations. So nadir mode is basically where the instrument is just pointed straight down towards the Earth. And we'll do that for 16 days. But on the 17th day, we will transition to what we call glint mode operations. In order to get meaningful scientific measurements over the oceans, we have to look at the sun's glint spot on the globe. So we'll do that for the next 16 days, and then we'll repeat that process. So we'll alternate between the nadir mode operations and glint mode operations. Now on top of that, every day we will look at one target on the planet Earth. These targets that we're looking at are what we call our observing network. So there are target sites, for example, in Lamont, Oklahoma, or maybe even in Darwin, Australia. Those sites will provide us the ground truth data so that we can do a data comparison and make sure that the scientific information that we receive from space is truly accurate as can be. Now I wanted to go ahead and close here by saying that the loss of the original OCO mission was a tremendous heartbreak for all of us. It was truly devastating. It was a true sense of loss. But as a member of that original OCO team, I want to speak on behalf of everyone that contributed there that we are excited about this golden opportunity to be able to finally complete some unfinished business. And this launch doesn't signal the end of a road, but it's the next step to a very important mission. Thank you. George?
Thank you, Ralph. And now for a look at Tuesday morning's weather forecast with Lieutenant Joseph Round, the launch weather officer from the 30th Operations Support Squadron at Vandenberg Air Force Base. Lieutenant Round?
Thank you, George. Late June, early July on the central California coast is marked by Pacific high pressure with low-level moisture trapped beneath the high in a pronounced marine layer. Currently, California is under the dominance of this high pressure, while an upper-level perturbation that passed through yesterday has helped to break up the typical marine layer. Looking at the satellite, you can see clear skies over the range with some evidence of the marine layer to the south. There's also a frontal system well off to the northwest that will ride over the high-pressure ridge and will not impact Vandenberg through the launch window. As the high moves back over the region, the marine layer will reestablish itself over the western coast, causing some lower visibilities and clouds through the launch window. Moving on to the day of launch forecast slide. High pressure will continue to dominate Tuesday evening, with a weak upper-level feature helping to destabilize the typical marine layer. For T-0, patchy fog and stratus are forecast along with thin cirrus associated with the weak upper-level feature. Visibility will drop to 1 to 2 miles in fog, and surface winds will be from the northwest at 5 to 8 knots. Temperatures will drop to the lower 50s at T-0. For the T-0 forecast, the probability of violation is 0% with no areas of concern. Moving on to the scrub forecast. A weakening of the high will cause the marine layer to slightly lift Tuesday evening through Wednesday morning. The resulting fog and stratus will be elevated and thicker, creating some light drizzle over the range. Visibility will increase to 2 to 3 miles in fog, and surface winds will increase to 6 to 12 knots from the northwest. Temperatures will remain steady, with the probability of violation for the scrub forecast at 0%, with no areas of concern. And that is all for weather. Back to you, George.
Thank you, and we're ready now to take questions. We'll start first here in the audience, and also media can post questions via Twitter by using the hashtag #PoundAskNASA during the briefings and while we're doing the questions and answers here at Vandenberg. So we'll start here in the front with Justin.
Thanks. Justin Wright with spaceflightnow.com for Tim Dunn with the Delta II back. What does it represent to you as a launch vehicle? Thanks.
Well, Justin, you know I have a little bit of a history with Delta II. I do dearly love this rocket. So when it appeared 3 years ago that we had flown our final manifested mission with MPP from Vandenberg here in the fall of 2011, it was a bit of a sad time for me. But I did know that ULA had 5 whitetails, Delta IIs that they had manufactured, and I knew there was some hope for the future. So our agency did take advantage of those whitetails and have since procured 4 of them. And so knowing that we now have 4 Delta II launches ahead of us, I'm thrilled. I've worked this particular rocket since the mid-1990s, and I've worked on both sides. I've worked on both the business side of it from the previous ULA side, which was McDonnell Douglas, and now for the last 13 and a half years, I've been with the government. So I've worked various aspects, and it's a wonderful program. What LSP is able to bring to Delta II is an amazing amount of skilled analysts and engineers with just an incredible amount of Delta II knowledge. So as a program, I know I speak for our program manager, Amanda Mickiewicz, when I say we couldn't be happier to be back in the Delta II business.
Okay, Janine?
Janine Scully, newshawk.com. What exactly, how long after launch do you expect to put OCO2 into operations?
Okay, so we have to again complete what we call the in-orbit checkout phase. That's going to take on the order about 6 to 7 weeks. So the first phase or sub-phase would be basically to check out the spacecraft and configure the spacecraft for in-flight operations. And then we'll take on the order about 3 weeks to go ahead and complete those series of maneuvers that are needed to get the observatory up into the operational A-train altitude. And then finally, we'll take on the order about 7 to 10 days to complete the checkout of the instrument. So if you add all up those times, we're looking at about 6 to 7 weeks nominally in order for us to begin the science data-taking portion of the mission. Now, we still have to go through an intensive period of making sure that the science data meet our requirements, and we'll be doing our best to try to go ahead and expedite that process. We are committed to going ahead and producing data that anybody throughout the world will be able to get from the OCO2 mission in early calendar year 2015.
Yes, right here.
Ewa Blaisdell, representing Ekspres Wieczorny, Poland, Central Eastern Europe. First of all, congratulations to the entire team. As a citizen of Earth, citizen of the United States, and originally from Poland, my heart goes out in a joy to see the effort and results. And also, I am delighted to see NASA leading an effort. Our readers and viewers would be very much interested in hearing something that you just concluded your answer with, which is how will you use rich data? And you mentioned that a lot of people can access OCO2 data, but specifically, could you share with our readers how could people all over the world benefit and support you also in your efforts?
Well, maybe I can start, and then Betsy, as a representative of NASA headquarters, can go ahead and follow up here. So we are first and foremost a scientific mission. Our number one priority is to make sure that we complete our objectives here. And that's to get carbon dioxide measurements with the precision, resolution, and coverage needed in order to better understand the global carbon cycle process as well as the climate change processes. As I stated earlier, the data is available to anyone, will be freely available to anyone. And we are working with potential users out there through what we call a series of science data application workshops. We want to reach out to the greater community because in the end, we want to be able to provide data so that people can make better informed decisions. We're not targeting a specific set of people, but we want to maximize this investment that the American people have made with the OCO2 mission.
So corporations, for example, can access also the data in order to help understand our good or bad behavior on Earth?
The data will be freely available. It will be stored at the Goddard Space Flight Center. And as I mentioned, we are looking to not meet, but hopefully be able to beat our schedule of being able to start producing data so that people can take the data from the archive in early calendar 2015.
Okay. Betsy, do you want to add to that?
I just would like to add that after this panel of folks are done, we will have our scientists up here to also talk about some of the scientific advances that they're looking forward to as a result of the OCO2 data.
All right. Steve Cole from headquarters has been monitoring the Twitter feed, so he may have some questions.
Right, George. We've got one question from Twitter at this point. How large is the carbon footprint for the OCO2 launch? And in your view, is the mission worth this additional carbon burden on the atmosphere?
Maybe it's a two-part question. Maybe my colleagues on the right can answer the investment, because that really is an investment. We need to take a look at anything that we do always comes with the price, but we also need to take a look at the maximum benefit of that investment. So I don't have any specific numbers about what it takes to get a satellite up into orbit, so maybe Vernon or maybe Tim can address that question. But from an OCO2 project perspective, we feel that a price like that is a small one to pay for the wealth of information that we expect from this mission. We hope, right now it's a 2-year mission, and we hope we're going to be able to get an opportunity to fly an extended mission and again maximize the benefit to the American taxpayer.
All right, Steve, any other questions on Twitter?
Not at the moment, George.
All right. Well, in that event, that's going to wrap up this briefing. We'll pause just long enough to change our participants on the dais so that we can now talk more directly about the science that OCO2 will be gathering. So we'll be right back. Thank you.